example 7, find the missing parts of the triangle. Once again, do a quick inventory of what we know. I know it's a right triangle, so we can use one of these techniques on this sheet of paper. I know one side and I don't know a second side. So I don't know any angle, but I know two sides. So now when I look at this piece of paper, I'm looking at the blue directions that says given two sides, what do you do? So once again, there's three things I want to know, A, B, and X. So I'm going to make a little box over here with my answers. A equals something, B equals something, X equals something. There's where I'm going to put all my answers. Step 1 in this process says to use the Pythagorean theorem to find the third side. So it's a right triangle. We know two of the three sides, so the Pythagorean theorem is usable and advisable. So x squared plus 6 squared is equal to 7 squared. Okay. Recognize leg, hypotenuse. Make sure you recognize what each thing is to create the Pythagorean theorem correctly. 6 squared is 36 and 7 squared is 49. So since I have 36 on the same side as x squared, I have to move the 36 over, so it subtracts. So x squared is equal to 13, which means x equals the square root of 13. Calculator can evaluate that. The square root of 13 is equal to 3.61. So, again, that's the very first thing I personally do when I know two sides. I go ahead and find the third side because the Pythagorean theorem does that for me. The second thing I do, it says pick an acute angle you wish to find and determine the opposite adjacent hypotenuse for that angle. All right, so in other words, it's up to you. Do you want to find A or do you want to find B? It doesn't matter which one you find. You have to find them both eventually. It doesn't matter which one you find first. So Erica, do you want to find A or B first?
A.
So Eric wants to find A. So if we, for angle A, pick the acute angle and find the opposite adjacent hypotenuse for that angle. So if we're working with angle A in the corner down here, if I go across the triangle, the opposite measure is 3.61. The hypotenuse is opposite the right angle, that's 7. And the adjacent side is the remaining side, like so. That's all step 2 tells you to do. Pick the angle you want to find and identify opposite adjacent hypotenuse for that angle you picked. Step 3 asks us to determine the sine or the cosine or the tangent. Not all three, just one of the three. So let me real quick write down SOHCAHTOA. Now what I was telling you guys yesterday when we saw this scenario was focus on what they tell you, what's given. 6 is exactly the length of this side, 7 is exactly the length of this side, 3.61 is approximately the length of that side. So if I'm looking at the three sides and asking myself what's going to give me the most reasonable answer, the most accurate answer, the numbers they gave me in the problem, 6 and 7, represent the two sides that are exactly right. 3.61 represents the side that's sort of kind of right. We've rounded it, we've approximated it. So if I'm looking at that and I see that the sides they gave me are the adjacent and the hypotenuse to A, it tells me that cosine is the best one of the three to pick. Okay? If you pick sine or tangent, I'm not going to count it wrong. I'm just saying if you want the most accurate answer possible, pick the one with the sides you know from the problem. So, cosine of A equals adjacent over hypotenuse. Anytime you write a trig expression, it's trig function of some angle equals some fraction. That's how you write these fractions, these proportions out every time. This time we don't know the angle. We know both sides. All right? And what I told you about on yesterday is if you want to know what the angle is and you don't know what the angle is, you're going to use the inverse cosine. And don't change it to a decimal. Keep it as 6/7. 6/7 is exactly right. If you punch in 6/7 in the calculator, you get some decimal around it, you're now making it less accurate. So I go to my calculator, I hit the second button, then cosine, so it says cosine -1. I'm going to type in 6/7 and parentheses. So whatever cosine equals, you do the inverse cosine of that number to find out what A equals. we get 31.00. 0.00271913. Okay. If I'm rounding a to 2 decimal places, that comes out to 31.00, right? So that's steps 3 and 4. I did those together. I determined the cosine, and I did the inverse of that cosine function to find the angle measure. Step 5, it says subtract from 180 to find the other angle measure. Well, now angle A is 31.00. So to find angle B, I'm going to do B is going to equal 180 degrees minus 90 plus 31 is 121. So if I subtract those, I'm going to get B is equal to 59.00 degrees. Now real quick, let me just go back to this part here, just to show you what I'm talking about. I'm going to group that and make it a little bit smaller, get it out of the way. Suppose right here, instead of doing cosine, I chose to do sine instead. If I'm doing sine, sine of A should be the opposite measure over the hypotenuse, right? So sine of A equals 3.61 over 7. Okay. Just like here, I didn't know what A was, so I had cosine equal, so I did inverse cosine. I don't know what A is, and I've got sine, so I'm going to do A is equal to inverse sine of 3.61 over 7. A equals 31 degrees. That's just what it equals, right? 31.00 degrees. My decimal point disappeared when I grouped it. Right, so when I do my inverse sine of this, that's what A should still equal. Inverse sine of 3.61 divided by 7. Now it's 31.045210.8. If I round that, that's 31.05 degrees. It's not exactly the same answer. It's off by a little bit because, again, I used an approximate value to find it. So again, that's not a wrong answer, but it has error built into it because we used an approximate value to get it. Okay, in math, we're always trying to avoid error as much as possible. And error doesn't mean wrong. It means not as accurate as it could be. So when you make this decision in step 3, sine, cosine, or tangent, I'm telling you, if you pick the numbers they gave you this number and they gave you this number, that's adjacent hypotenuse, so we did cosine. That's going to get you the most accurate answer. If you use the one you found with the Pythagorean theorem rounded, that's going to give you a less accurate answer. Still not wrong, just not as accurate. So make decisions like that when you're going through this. I'd prefer to see the most accurate answer, but again, if you get it right, I'm not going to count it wrong. Just try your best to get the most accurate answer always.